All right, I'm going to show you how to work through a chi-squared on PSPP. This is very similar to SPSS if you are using that software. What I've done is I've gone in and loaded data that is similar to the pretend data we were talking about this division of new clients going to Sal versus Sue and what the gender of the client is. So I'm going to show you both the standard chi-square and then also the chi-square test of independence. So for the regular chi-square, we're going to go up here to Analyze. We're going to go to Non-Parametric Statistics, and we're going to go to chi-square. Now, we're going to start with, so our variables would look like this. So let's start with a regular chi-square to say, are the two sales reps getting an even distribution of new clients? I'm going to show you how to do this two different ways. So move sales rep over here. And let's start with all categories equal. So this is where you're proposing that there is going to be an equal split between all of the categories. Obviously, we only have two possible categories. Clients are going to Sal or they're going to Sue. You could do this with several different categories and the software would calculate out the ratios for you. So we don't really have any other settings to mess with here. Click OK. And you will see on the output, if I can get it on the right screen, a very simple set of tables. This is showing you your observed versus your expected, what your residuals are, what your chi-square calculation is, and the statistical significance. So if we were expecting a 50-50 split between clients, we would have a statistically significant result that Sue getting 165 clients and Sal getting 55 clients. Remember, what our null hypothesis here is that our data is breaking down the way we're expecting it to break down. So for a 50-50 split, that both groups are equal. So our null hypothesis would be there's no statistically significant difference between groups. There is a significant difference between groups, right? So we reject our null hypothesis. We say there's a significant difference between the number of new clients that Sue is getting versus Sal, if we're assuming it's going to be a 50-50 split. But now let's do something different here. Let's say maybe we didn't want a 50-50 split. Come back to non-parametric statistics, click chi-square, and let's say we're dealing with a scenario that maybe Sal only works part-time. She only works about a third of the time over in sales, or he, whatever Sal's gender is, only works about a third of the time over in sales, and the rest of the time goes and helps with stuff in human resources. So we don't expect Sal's sales to be an even split because they're not always in the sales department. So we could allot this on values. I've done a calculation of what we would expect the number to be if 70% of all the new clients were going to Sue and 30% of the new clients were going to Sal. Now, one thing to pay attention here is your coding. Let me back up a little bit. Over here on variable view, what I did was I told the computer that I wanted this coded, that if I enter a 1 for the sales rep, it refers to Sal. If I enter a 2 for the sales rep, it refers to Sue. And just so you can see for our next analysis, I also did the same for male and female. 1 is male, 2 is female. So now, I need to remember that I had said that 1 is Sal and 2 is Sue. Because when I go back over here to my analysis, the first number that I enter for my expected value is the one that it's going to assign to the variable that is coded as 1 on the sales rep. The one that I enter as my second number is the one that's going to go to the variable coded as 2 on the sales rep. So what this is going to do, if I proposed a 70-30 split, is I'm saying I expect Sal to have 66 new clients. I expect Sue to have 154 new clients out of the 220 new clients I got during this time frame. So now when I click OK, where did my output go? All right, you will see, so this one's down here. Wait, where did it go? Yes, this one's down here. On this one, I expected 66 and I had 55. I expected 154 and I had 165. So in this situation, I do not have a statistically significant result. So I cannot reject the null hypothesis because the actual observed split of the clients is not significantly different than the expected split of the client. And so that's all that's involved in a chi-square test on PSPP or SPSS is these two simple little tables right here. Now let's do the chi-square test of independence. This one you go to in a different spot. We're going to come over here to analyze, compare means, no we're not, descriptive statistics, and do a cross tab. Remember I showed you how to do this when we were just comparing numbers at the beginning of class for our descriptive statistics. So what I'm going to do in this situation, when you first open the window, it would look like this. I'm going to tell it I want to consider both the sales rep and the client gender. Now, I have some options on this one. Over here on format, we want it in a pivot table format. Don't worry about that. On statistics, I can come up here and tell it I want a chi-square. And it'll give you a little pop-up that this will measure the Pearson's chi-square likelihood ratio, et cetera, et cetera, et cetera. I can also ask it for my phi if I want. But we're not going to do that right now. We're just going to focus on the chi-square. Continue. And cells, I don't think you need to. You could look at the expected and the residual in the cells. Now, just so you know, this number is going to come out a little bit different than the number we did on Excel, because in Excel, if you remember, I rounded up my percentages. I made an even split 70% and 30%. What is this? Go away. 70% and 30%. It was actually something fractional. It was like 69.62% or something like that. So I rounded it for it to be clean. It's not going to be rounded in PSPP. So the number is going to be slightly different. So we're going to click OK. And now our output looks a little more complicated. This is verifying that I know the sales rep and the client gender for all 220 cases. I didn't have any missing data to deal with. And this one is showing me for my sales rep, Sal had 25 male clients and 30 female clients for a total of 55. And it's going to give me my expected for each one. And you can see here there's the difference of the 38.75 and 16.25 since I had rounded my percentages. And same thing with Sue. We had 130 new male clients, 35 new female clients. It would have been expected 116.25 and expected 48.75. Now, what we're going to do is we're going to scroll down here, move this, hide that, and we're going to look at the Pearson chi-square ratio. And we can see that it came up with a value of 22.02 for this chi-square test, and that this was statistically significant. And to just check this with our Excel over here, we had come up with 21.847 or 21.85. So 21.85 compared to 22.02, that was a rounding error. So what we can see is that this is how it would look doing this test to show that we did have statistical significance. If we were dealing with ordinal values, we would look down here at this linear by linear association, but that is a topic for another time. So that is the ins and outs of running your two different options for your chi-square test using our software.